Hari, thank you for that warm introduction. I hope my screen is visible. I'm sharing my slides. Yeah. So, guys, hi everyone. So, today we are going to talk about managing the different types of window microservices using Nomad. I know people have a different perception about the orchestration services. A lot of people use Kubernetes and all, but here I want to give a different view of Nomad, which I get to learn about while doing an interesting project. So again, my introduction has been already in by Hari. So I'm a DevOps consultant working with Opsi Solution. I'm a technology enthusiast, and I'm an open source contributor as well. I do contribution in HashiCorp projects and the projects like Kubernetes, Prometheus. So I'm one of the developers on those projects as well. So that's it about me. Yeah. Here, before going to the main part of the Nomad orchestration using the Windows microservices, here I want to give a little walkthrough of the Nomad as an orchestration engine. So I guess a lot of people already have the context around it, but I just want to give a little bit of glimpse of it. So basically, HashiCorp Nomad is an orchestration platform which can manage a microservices environment and which can manage a complex microservices environments very easily. And one of the very good benefit of using the Nomad is that you are not restricted to use only containerized applications. So while other orchestrators are limited to the using the containerized applications and all, you can run non-containerized applications as well using the Nomad. It can run used for the running the deployments. It can be used for running the batch jobs and many other purposes as well. Also, Nomad comes with another beautiful product of HashiCorp, which is called Consul. So you can integrate Nomad and Consul, and through that you can achieve the service mesh and the other features of it. Other than that, Nomad is a cross-platform. Since it's written in Golang and designed in Golang, it can support the different platforms as well. So, for example, you want it run on a Mac OS system, you want to run it on a Windows system, you want to run it on a Linux system, you don't have to worry about it. You can run it very easily. Now, next question is that when we already have a lot of orchestrators available in the market, why do we need Nomad? So one thing is that I love about the technologies which enables the plugin mechanism, where we have our own custom plugin and we can club it to the main system and we can do anything about it. So for example, that is one philosophy on Nomad is based on. So basically, it is not restricted to running the microservices on the container basis. For example, you would directly want to run the Java applications. You can integrate the Java plugin with the Nomad and you can run the Java application. And let's say you want to do the virtual machine management using the Firecracker, you can integrate that. And other than that, Nomad provides an extension point in terms of the custom plugins where you can write your own custom plugin, which we have done so far. And you can integrate that custom plugin to the Nomad, and then you can leverage the functionalities of the Nomad. So that's what we did with the our project, which we are going to explain in the further slides. Now, again, another reason of using the Nomad is that while the other orchestrator have this little bit dependency on the Linux operating system and they work great with the Linux operating system, but for the other operating system, they are still in the development phase and they are evolving. But the one thing is the Nomad is that, again, we have explained that it's a cross-platform binary which can run on any kind of system. So for example, here, if you see that our Nomad and Consul server is running on the Linux platforms, but you can run the Nomad clients on the Windows platform as well. Since it's a OS independent project, so you can install it on the any kind of operating system, any kind of architecture. It's not always restricted to AMD kind of architecture. You can run it on ARM based system. You can run it on over a Raspberry Pi system as well. So that is also a possibility which we have with the Nomad. So that's a really cool thing about the Nomad. And these are some other reasons which are already part of the a basic orchestrator functionality, that Nomad supports the auto scaling. And it not only supports the auto scaling, it also supports the integration with the different metric system. For example, you can integrate your Nomad with some other monitoring system. For example, you can integrate with the Datadog, we can integrate it with the Prometheus, and from the metrics calculation, you can do the auto scaling. So for example, whatever the metrics we are getting on the basis of threshold, I want to do the auto scaling, I can easily do the auto scaling using the Nomad with the other projects. And the failover part is also there. So one thing with the orchestration engine is that once my application is ready and running, then only it should serve the request, and if it is not ready, it should not serve the request. So that's the bare minimum functionality which orchestration engine should support, and that is already supported by the Nomad. So let's say if I have a set of microservices running, and let's say, and those microservices have different replicas, so let's say 5 or 10 replicas of those microservices, and on the basis of that, basically in between those 5 to 10 replicas, two replicas are not responding. So the orchestration engine will not send any kind of incoming request to those systems. It will send the request only to the healthy system. So that is the failover is also the part of the Nomad orchestration engine. Then metrics monitoring. So basically, Nomad has a it's a direct instrumented project with the Prometheus. So basically, when we say directly instrumented services, in that case, you don't even have to install the agent. For example, I directly want to monitor the Nomad and then let's say Consul to the Prometheus. I don't have to install any kind of agent. I just have to enable some specific configuration, and after that, I'll be able to monitor the complete platform on the Prometheus like system. And let's say if we don't want to use Prometheus and we want to use some other metrics monitoring system, in that case as well, we are not restricted by the functionality. You have different agent available for the Nomad monitoring, which you can install, and you can monitor your complete Nomad cluster. For example, you can monitor it over the Datadog, Dynatrace, other monitoring system. Then service discovery. So service discovery is not technically the part of the Nomad service. Nomad directly does not support the service discovery. You have to integrate the HashiCorp product, which is called Consul, which is specially built for the service mesh and the service discovery concept. So basically, you can integrate the Consul with the Nomad, and through that you can achieve the service discovery between your microservices inside the Nomad cluster. And then nowadays, this is a very popular concept of the service mesh, where we have to create end-to-end encryption connection between two services. So basically, that is also one of the things which Nomad is supporting with the help of Consul. And with the Consul Connect, we can install the Envoy proxy as a sidecar, and that can help the microservices talk to each other in a secure fashion. So service mesh and the service observability is also one of the things which is supported by the Nomad large widely on the complete cluster. Now, this is the main agenda which we wanted to talk on. So basically, the major problem statement that we have while working on something, that we had a project called a traveling site. And on that traveling site, the thing was that they were running the major applications on the .NET applications. And it was not .NET Core 5, so that was they were managing over the Kubernetes and other platform, but they had a large chunk of applications on the .NET applications, and those applications were running on the static Windows instances. But the challenges with the static Windows instances were a lot. First thing, that we did not have the scaling, because those were static instances, so scaling and downscaling is something which was not part of the scope. The failover, whatever the thing which we have mentioned on the previous slide, that was something which we were not able to do on the Windows based microservices. And since they were using Kubernetes and orchestration engine, they did not give a thought about some other thing. But while working on the Nomad, I came across this amazing concept of the plugins. And so what exactly we did as a solution, we identified a plugin which is supporting the IES drivers of the Windows, which is called the Nomad driver IES, which is created by a Roblox organization. And we forked that project, and we did the further development on it. So what exactly Nomad supports, that you can create any kind of custom plugin and you can integrate it with the Nomad system. And once you integrate it with the Nomad system, in that case, you can leverage the Nomad functionalities with those plugins. So this is what we wanted to do. So what we did, we took this Windows IES plugin, which was open source, we customized it, and we integrated with the Nomad system, so that we can take the leverage of Nomad system. And after that, whatever the .NET based applications we had, we were able to manage those .NET applications using the Nomad platform very easily. Now, this was the solution architecture we had while working on this particular project, that over the period of time, we completely migrated to the orchestration engine as Nomad, because here we did not have the complexity of managing the two different orchestration engines. A single orchestration engine was able to support our both functionalities, where we have to run some Dockerized applications, and another use case was running some custom applications of the IS sites, which is based on the .NET based application. So what exactly we did, we created the pool of three Nomad leaders, and on the basis of that, we integrated the Consul servers. And after that, we added the agent to that Nomad leader pool. Now, in that case, we have a Linux follower, we have a Windows follower, and we divided it. So basically, whatever the applications which were running on the Docker engine, we were targeting for the Linux follower. So all the Dockerized applications were running on the Linux follower pool. Then whatever the applications, we have the .NET based applications and we wanted to run it over the Windows platform, we installed our custom plugin on those nodes, and we targeted all the Windows based applications on that particular node pool. In that case, a single orchestration engine was able to support our both use cases. We were able to run the .NET based applications, which is completely restricted to the Windows, and we were able to run the Dockerized applications using the Linux followers as well. So that is the solution architecture we came upon on using the Nomad orchestration engine. Now, the question is that how did we able to enable that custom plugin? So basically, Nomad provides you the some set of configuration where you have this functionality. You can enable your own custom plugin. So basically, you see that I have highlighted this particular area where I can define that this is my plugin directory and where I can store my plugin. And once we have stored that plugin, the Nomad will automatically pick it. And after that, whenever you have installed the plugin, you have to enable it, because by default the plugins are disabled in the Nomad. And whenever you are integrating a custom plugin, or let's say the existing plugin which is supported by the Nomad, you have to enable it. So here we have enabled the plugin called WinIS, which means Windows IS system. And then we have enabled the configurations. And once we have done this, that's it. Our Nomad platform is able to run the .NET based applications on the IS sites very easily and without any challenges. Now, this is something which is interesting here. So basically, we have the job and task, and on the basis of this job and task, we have like a definition of the job and task of the IES configuration. So basically, if you see here, we have created our own custom block inside the Nomad, which is called this config block. So this is something which we have as a generic block inside the Nomad, where you have to define the name of the job, you have to define the data center, then you have to define the type of service, and you define the count. This is something which is a generic concept of Nomad and supported in all plugins. And again, this is also something task set which is enabled, which is custom, which is restricted to this custom plugin only. So basically, in the task, you have to define the driver which you are using. So for example, if I'm running a Docker based application, I say that in the driver I want to use Docker, and then I define the configurations related to Docker. But here I'm using the IS as a custom plugin. So I say that this is my driver and this is my artifact. So artifact is something where we have to provide that the application which we want to deploy, and I'm providing the driver. And once I have defined this, there's a configuration block. Now this configuration block is something which will always update on the basis of driver. So let's say in my case, the driver is Windows IES. And according to that, I have to define my configuration related to IS configuration, where we have defined the path where my application will be running. The application pool identity, this is something the IS property which we have to define, that I want to use the network service, I want to use some other IS property. And let's say the bindings, what should be your bindings, the type of bindings. For example, the application is running in the HTTP form, or is it running on the TCP form, and the label of the port, something like that. And let's say if the driver was Docker, we have updated the configuration, we have to update the configuration related to the Docker part. But since we are running the custom plugin WinIS, accordingly we have defined the configuration here. And that's it. Once we have defined the task definition of the complete job of the Nomad task, we will have a picture like this. So basically, the allocation will be starting running on the Nomad cluster, where you see that my two IIS applications are running here, and those are being registered on the Consul server. So if we want to identify these things, we can easily see that whatever the services that being are created on the Nomad, that are being also registered on the um, Consul as well. And you can see that this is registered via Nomad is already highlighted here. So basically, this is how a single platform we use to manage all type of application, whether it's a Linux-based microservices, whether it's a Windows-based microservices, we were able to manage very easily on the Nomad platform. Now, let's say if you want to simulate this complete environment, what exactly we have done, let me share my, again, another tab of complete screen. Let me share it. Yeah. I think you will be able to see my entire screen now. on the entire screen, now you can see this is a project which we have prepared, which we already have mentioned on the particularly slides as well. On the slides as well, I have shared the link of it. So this is the Nomad driver IES plugin, which have the complete simulation of it. So basically, it's a Go plugin which can be compiled and stored inside the client machine, and then you can run it. So basically, to simulate this particular project, I have created a Vagrant project. So basically, this Vagrant project is something which can be used to run the complete application. So basically, you don't have to do anything. There is a Vagrant file present here which can do the complete simulation of the project, where you want to run a Nomad server, a Nomad client, a Consul server, and it can install the plugin as well, and it can run your application as well. So basically, this Vagrant is also one of the HashiCorp project which we have used. It will use a Windows image, and on the basis of the Windows image, it will install all the necessary thing. For example, if I go to the scripts part, I'll explain it here. It is using a PowerShell script where it will install the Git, Golang, Consul, Nomad, and after that it will creating the services and all. So once this has been created, your Nomad and Consul service will be running on the same system. And then once it is ready, you have the example folder here. And inside the example folder, you have the IAS test Nomad, where the complete example is available, where you can define this complete data centers, type, count, and the restart details. Then you have the drive task. In the task, we have defined the driver equals to WinIAS. And then we have defined the source artifact. So this is a sample.NET based application project, which I have already uploaded so that people can test it. And then in the config path, we are defining the IS related configuration that I want to use. Netcore app is the application name, and this is the task directory. It is available here. And then we have the app pool identity. We are defining the network service bindings, and this was something which was not supported by default inside the this IS driver plugin. That's why we have forked in and we added this customization. So basically now it is supporting the resources block as well. So CPU memory can also be restricted for a process. So basically it's nothing like that. You can run the service and that service can choke up complete CPU and memory of a system. You can always restrict that process in terms of CPU memory. So that is also one of the functionality which we have added here. Then we have the service block, which is registering all these services to the Consul system. So if you want to try this complete simulation, please go through this project. Please try to simulate it. And let's say if you face any issues, you can open the GitHub issues and I'll try to fix those things. But yeah, I have already tested this project multiple times. I use it for my development. So I really doubt how it will show any issues. But let's say if you want to see how exactly we can build this, there's a documentation available in the form of particularly markdown format, the readme format. So in the readme, we have defined how you can build a plugin, how you can configure it, and how you can run your job. So all the things are in place in the terms of readme file. So do check out this project and let us know that if you face any issues and all. Now, again, I would like to do the summarize of the complete things which we have explained till now. So basically, a lot of people have this perception that when we talk about the orchestration, they think about Kubernetes is the only orchestration engine available right now in the market, which is super successful and can run all kind of microservices. But there are few things for which we can always leverage orchestration in systems like Nomad. So for example, here we have a custom plugin requirement where we have the Windows-based applications and we cannot run it on the Kubernetes. The reason was that the Kubernetes is not that much stable on the Windows side, and we identified that Nomad is something which is supported on all type of platform, and we can leverage that. So we decided to go with the custom plugin. We integrated that custom plugin inside the Nomad, and we were able to run all the Windows-based microservices, which we were not able to do that. And once we integrated this system, we have the functionalities of auto scaling, failover, and all those things of a basic orchestration engine inside our applications. And right now we are running around 250 microservices over this Nomad platform on the Windows part, particularly. The Linux is different, but Windows microservices, we are running around 250 microservices using this particular plugin and the Nomad platform. So that is one of the things which we talk about. So basically, you can always look for a better alternative rather than relying on the popular solution, which can provide you the more suitable functionalities related to your system. So that is something which we have done with the Nomad. So yeah, that's it from my side. If you guys have any questions, please let us know.